All right, guys. So we're getting started. This is the first workshop for this semester. Rag to Riches. Huang will be hosting the Retrieval Augmented Generation workshop. It's a catchy name. That's why we came up with it. It's like actually Huang came with it. It was like a nice name, and we'll have some cool announcements. I think maybe we'll do them when we'll be distributing out the pizzas or like by the end. We're having this hackathon by Google this semester, and we have a couple of other workshops coming up, so we'll talk about it later. Anyways, giving it to Hong.
Okay, good evening, you guys. Welcome to my workshop. This workshop will be focused on retrieval augmented generation. Typically, the what's, why, and how this rack came to be, or like what is it, and how can we use it. Along with that, in the middle, we're gonna have a little bit of code along, where you guys will build your own uh, rack pipeline. So the general agenda today is I want to explain to you guys how did RAG came to be, like what problem does it solve, what exactly is RAG, and what and how can we use it. We will learn the pipeline of RAG behind, like the pipeline behind the scene, and see how the input be transformed to a relevant like output. So we're gonna go through your first RAG project, learn to interact with text encoder and vector database through Hugging Face and ChromaDB, and finally utilizing the retrieved info to augment your own LLM generation.
And vector database.
So going into why RAG came to be. So before RAG was, I guess, invented, the LLM space has a bit of a problem. While the LLM is very good, or like at least decent in reasoning, uh, and it packs a lot of common knowledge into itself, into the model weights. And also it can be a great generalization tool where you can just provide it context about basically unknown tasks and it will still be able to do it. So the challenge it consists of three things. First of all, the model weights. Pre-training the LLM or like just fine-tuning it in general is very, very expensive. You guys might have heard like a lot of big companies is trying to build AI data centers, mostly for inferencing, but it's also double as like a pre-training ground for them to like just train LLM models. And the data that they use can range from like I guess thousands of terabytes to like millions. Uh, so yeah, that's one problem with pre-training or like even fine-tuning where you need like I guess at least like 1,000 data points to at least make your model follow what you want. Uh, Aside from that, the model is very like it encodes a lot of pre-trained knowledge into it, but it cannot follow with the recent events. We as human kind of produce a lot of information day by day, ranging in hundreds of terabytes. But we can't just feed it all into like an LLM because training them all already like takes 1 to 3 months. So we can just use that method to keep updating the model. Apart from that, there's also the context window. Even though like the current LLMs can go up to like 1,028, uh, 128,000 tokens for the context length. A lot of the time, for a smaller model or like edge device, the model is very limited by their context window, and that remains like a problem before RAG came to be. So going into what is RAG. RAG consists of uh, three main key points, which I have listed here. The first one is retrieval. This is basically gathering information or raw data that is relevant to your own like question and query. For example, like ask an LM like, what should I wear? It wouldn't know by in its memory, like what temperature is today. So it needs to pull that information from somewhere else, either by you providing it or it searching the internet itself. So in an ideal world, it would search up like the today's weather, see what temperature it is, how humid it is, and just recommend what you should wear. And the second part is the augmented. Basically, just after you get the information, it's just appended to your question. Usually following like standard blueprints that is provided and tested by people. So for example, here, question, what caused the solar eclipse? And after you retrieve the context, which is a solar eclipse occurs when the moon passes between the sun and earth, blocking sunlight, you just put that context in the middle and then give it all to your LLMs. And then it will use that context to properly answer your question. And finally, generation, it's just using the prompt on your own LLM. Oh yeah, sorry. You see the picture here, there's a little bit of the high level pipeline on the top. The usual question, retrieve or search through the vector to find a relevant context added to the prompt, and then LLM writes a very, I guess, answer for it. And you can see here example with ChatGPT. My query is, what is the latest trending technology right now? So it kind of think it thinks, but it also like go through a bunch of websites. Like here is like I think it's 19 websites just to get the relevant trends in technology. And also for YouTube, I think they also use like the subtitles of the videos as like a file for the LLM to be able to answer something like summarize a video. So behind the scenes of every RAG pipeline, there's two main process. The first process is encoding. Encoding consists of three main steps. The first one is chunking. The chunking is where, okay, let's say, for example, would you like a person to just give you 16,000 documents, read it all at once, and find the specific info inside of like all those 16,000 documents? Or would you rather them already retrieve like the relevant info and then give them to you along with the question? So most people prefer number two, right? And that's how the retrieval in the RAG works also. You would basically convert documents into a bite-sized version of itself, either through the sentence by sentence, paragraph by paragraph, or just like a semantic blob. Semantic blob. And you would then encode the data using another machine learning model, a text encoder specifically, and you to convert all of those text data into vector embeddings so that the machine could understand and do comparison. You can also store extra like info, metadata like title, source, page, section headers to basically provide you a way to evaluate how correct the model, the retrieval. And finally, after converting all the text into embeddings, you need somewhere to store it. And you will store it in a specific dedicated vector database, something like ChromaDB, Pinecone, or like Postgres with PG vector. These are supported vector embeddings, and they also have their own inbuilt vector search, which is basically trying to search the nearest vector query. So going to the second main process, querying, you would have you as a user would have question, and in the backend, that question would be taken and processed using the same text model that we use in the encoding. This part is like very important that you use the same embedding model as when you're encoding the data, specifically because imagine each model as like one of your friends, right? You wouldn't you wouldn't think that two of your friends basically have like two different lives until now to think of the same topic similarly. I mean, you can it can be like that, but usually they have some type of difference that's affected by their like own bias and experience. So this so to highlight this point, use the same model, text like encoder model for your data and your query. You like just one single person encode the data in the query. Yeah. So the second point is when you do context retrieval, usually this just means like doing k nearest neighbor search if you're familiar with machine learning. Or in the industry standard right now, they use something called HNSW, which is the abbreviation for something I kind of forgot now. But yeah, you guys can search that up. It's less accurate than k nearest neighbor, but it's way faster. So yeah, finally, it's just prompt engineering. It's appending the context, relevant context to the question and feed it to the LLM. So to recap, why is RAG invented? Specifically because normal LLMs has rigid or stale information encoded into them. Their context in the window, especially for the lightweight models, is limited. Secondly, what is RAG? RAG, to sum it up at a high level, is basically a way to add relevant context for the LM to answer. And then how do we use RAG? Uh, two main process, encoding and querying. And inside encoding, we have storing the vector embeddings. And inside querying, we have a way to retrieve the relevant data from the storage. So yeah, let's get on to our first RAG project. This would be a small code along. I will send you a link, or you can just guys can scan it on your QR code here. But I will send a link to the notebook on Discord general, so you guys would be able to just access this on your laptop. Yeah. Any question so far? Any question on the RAG pipeline? Nice. Okay. Okay. After you guys like get into the notebook, go to like the files, and then save a copy in your own drive. Uh, yeah, just so that everyone have their own version and everyone can just code it on there.
That RAG allows LLMs to not have that outdated info,
Yes.
instead give real-time information. Is that having to do with the context?
So you want to ask specifically how exactly RAG like takes in real time information, right? So usually it's either by you giving it like some kind of document, like PDF, docs, or just like a pen. Sorry, not a pen. Use something called MCP, which is basically a two kind of a library of two base for the LLM to use um, to search the internet. So you can just like uh, make it search the Google and retrieve back like 10, 10 of the most relevant page. Yes, NCP is basically tools for LLM. Yeah, it's other agents. You can do that also. Yeah. Oh, maybe.
standard way of connecting different AI agents and LLMs together so that we wasting time doing APIs and all of that version.
Okay, that is interesting. Yeah, my understanding is that it's a more effective way for it to use API. They would know to use it. Yeah, yeah,
It's just a standard now
yeah.
instead of every way of doing it.
Yes. Okay. Yeah. Have you guys create a copy of the notebook? Can I have some like raise hands to see like the progress? Raise your hands if you guys like save a notebook to your own drive and open it up. Anyone having trouble just saving the notebook and and running it yourself? No. Okay. Notebook.
There's a lot of
Okay.
Oh. Okay. Yeah. Okay. After that, can you guys like also connect to the T4 GPU? Because we will be needing that to run the machine learning model. It specifically runs on GPU. Well, like not specifically, but I was pretty fast. So here we go. Okay. If you are able to connect to the T4 GPU, you can start by just running and installing all the libraries that we're gonna need for the RAG model. So right here, we have a whole bunch of libraries, but you just need to focus on Hugging Face Hub, the transformer, sentence transformer. Oh, I guess you could just basically, sorry, focus on the Hugging Face, just the Hugging Face, Dockling, Coma, and the Google Gen AI. For a bit of context, the Hugging Face is usually where you would get your open source machine learning model. Basically, the machine learning community decided Hugging Face would be the place where they just upload all their weight model for you to be able to quickly. Yeah. So yeah, it's a great website to check out to if you want to get into machine learning. Aside from that, there's also Dockling, which is a very popular in the industry for pre-processing PDFs and documents. Basically, it's just try to ingest the document and then export it into Markdown because Markdown is easier for the model to, I guess, ingest. Yeah, it has uh, loading and to importing. So importing, yeah, like I said, like the Hugging Face would have a library called Sentence Transformer, which is what we're gonna use today. Dockling, we're focusing on the document converter flow from PDF or docs to Markdown, and chunking, which, like I have mentioned in the pipeline, basically converts the document to bite-sized version of itself. And then ChromaDB is for storing all the embeddings and searching the most relevant vectors. And finally, the Google Gemini library import is just for the LLMs at the end. Okay, after this, I would like you guys to go to Google's AI Studio, get on it, sign in your Google, and then get your own API key. I will show you the process right now. Check.
Ash,
Yeah.
it's giving me an error.
Oh yeah, you guys can upload. Okay, let me just pull it up. As here. So the next step is basically just you guys upload your own document and then letting it convert to Markdown. So you guys can use like any document that you have, but most preferably PDF or docs. So yeah. All you guys, I'm gonna try. Let's see. When you're at this page, just press get started. Then if you guys haven't created an account, it will prompt you to agree something. Just agree to everything. Carefully add it. And when you're here in this screen, you see get API on it. Then you should automatically have your own API key automated. If not, you can just create your own API key right here. Yeah, just copy the API key and put it into so that you can you are able to access the Gemini 3 Flash. Reaching up to this step. Okay, let's go to the next step. Uploading your own document there. So to upload your document, just go into like the folder icon here, and then you will see like a bunch of empty space here where you can upload your own document. Also be using yeah, you guys can use any document, preferably PDF or docs, and preferably no less than 5 page because I wouldn't want it to take too long to run. I'm using my one of my research paper. Wait to upload. Okay, set transformer. Okay, and then run. It should take a while. Okay, anyone having trouble uploading their own document? Okay, let's wait for this to send. Thanks. Wait, officer, can you guys what is it? distribute the pizza?
We are waiting for the process to run.
HF token.
Right now, I don't know, it's on a proper scale system, like.
Your question is, have I built this on a large scale? Yes. Similarly, but for image. I haven't tried it with text, but yeah.
Just seeing a site.
Just Python, but I will go more into it later.
So I pulled sample data and give you. And I haven't tried it, like content slash and file name. It says. GC.
You just open.
Okay, it seems like this environment haven't set up the Hugging Face token yet. So let me pull up an example.
Looks like.
So to obtain your own Hugging Face, just go to the Hugging Face website. Search Hugging Face on Google. Go to the very first link. Log in. You don't have anything to sign up. Yeah, sign up. And then when you're at the main page, go to access token. Access token. And then create a new token. Set name, I guess, brag. And then take what is it? Yeah, read access to contents of all public gate repos. After that, just create your own yeah, just go down, create token. Remember to take the read access to public gate repos. Create tokens, copy it, and then go back to your it ran. Okay, never mind. But yeah, let's add a Hugging Face token here, just in case it doesn't work with you guys. You'll be able to use the same similar code for here.
Yes.
Okay, run this. Okay. Hopefully the warning right now. Anyone having trouble getting the Hugging Face token? Anyone need a free one?
This is the whole. Make my mouse.
Yeah, anything, yeah.
Who's going?
What is the access?
Oh, so read access to all public gated. Oh, sorry. Wait, no warnings, so it should be running fine this time. Also, don't share your API key, guys. I'm gonna replace this after this. If anyone needs help, just raise your hands. Our officer will help you guys out. I have chosen the long document.
Yeah.
You put it on the slide. You just put the. Yeah. This guy doesn't have Discord, so I have to email it to me. Oh, he put up the slides there.
Nice. Okay. So after we're done with uploading and processing your document into Markdown, the next step is to familiarize yourself with chunking, creating a smaller version of the documents, really either a list of sentence, a list of paragraphs, or just basically a list of 100 characters, so on and so forth. So here, as you can see, there's an algorithm here that basically just do chunking. And here, I have a little bit of to do here for you guys to practice on. And yeah, out with this. I will be coding along with you guys too. So let's wait. Okay. After stating the end, would be from the start character plus whatever. Next up, we will just define the chunk as from start to end. So this to the whole text. But so here, if we basically go through figure out the index of the topic, between two of them, put that into the you just append the single chunk into the text right here. We have a list. So we're gonna have a list of chunks. So you guys do that by just doing chunks dot append. So here it would in the end it would contain a list of text. And after that, you would update the start variable with a new index position inside of the text document. And let's just do that by appending start. Let's see. Oh, right, overlap. There's also overlap parameters here, which is basically you want the text to overlap with each other so that they don't lose all the context when they move on to the next. So for example, you sorry. That is a bad example, but let me
So once I get the token,
You think about that. Everything can overlap.
And have accessibility.
Basically, you guys don't want to be each chunk as a standalone thing. You want them to cover something around it. It will be able to gather like the surrounding context so that it would help gather with the retrieval process. So setting standalone is bad for retrieving. So with that overlap parameters, we would do chunk size. Whole loop just cuts again the very end. After that, we just run that. Okay, and then you will see a few examples of your own documents along with like how many chunks you create. No, it's like 5 pages. Oh, yeah.
Keep up.
Another thing is that for chunk size, it's best if you follow the context window in your embedding models. For example, the sentence transformer we are using, the mini LM, I think it's below here somewhere. Right, the sentence transformer, the mini LM, I would give it to you guys later, but yeah, its context window is only 256. So we are creating a chunk size of 266 in corresponding to that for better retrieval, better encoding, and better entry. So yeah, after you guys do this,
So maybe each.
then you guys run the simple chunk, move on to the hybrid chunking. Hybrid chunking basically is another method of chunking, specifically to docking. I don't know if any other company uses it, but it's in high level term. It basically separates the documents sentence by sentence, paragraph by paragraph, and then maybe it may be not depend on the attention to get it. Also, like basically just treat it as the better.
Like be able to.
I guess by percentage space, but it's more depend on your kind of data, how like how it's it's
Even all and chances. That be different from say your. Because there's going to be a trade-off at certain points, right? No, I know.
specifically, I guess less than more than that, then you would like it.
I mean, then your chunk is like 50% of.
Yes, I agree.
Yeah, I just use the hybrid chunking, so general overlap. Yeah.
I was like, you get the bitch. I'm like,
Anyway, to hybrid chunking, we will be using like a hybrid chunker function from Dockling. So it would be much more simpler to implement. I just want you guys to put in like the 3 parameters that is needed inside the function. And merge peers. Merge peers is basically if you want the Dockling to combine sentences to make a whole and so like put it false. We know that like the whole thing is like context window. Because for example, if 2 sentences have like so and the document decides to put it together, it exceeds the 256 I'd want to turn the merge PR. Do it off, right? Then run it. Hold on. Okay. It might warns you that some length is longer than the maximum context window of the model, which is but you guys can also anyway, just you don't have to care about this. After that, you also have like firm chunk. So exactly. And then after that, we will go with converting chunks into usable variables for so just run. Two chunks here, but we're probably going to okay. Let's move on to loading the model. So to load the model, we have the embedding model name here, which is all mini LM 62. This is a pretty lightweight model, which is why it's only trained on content 56, maximum of 512, but it's preferred by the author. So yeah, we'll be using this model today. It is very lightweight, so that it works. So we will be using the sentence transformer function from the Hugging Face. You guys just copy this function and then add the embedding model name. Then yeah, we would have like a variable. And then also add like a little bit of example code down here for you to see. So after you run it, you see something like this. So the maximum embedding dimension is 384, and anyone having trouble reaching this part? Loading the section transformer. If not, we'll move on to InformaDB, which is the third part about our pipeline. Very important part because it gives us a way to store the vector embeddings as well as search it. What we'll be using today is the open source InformaDB, a vector database library. And here, I would like you guys to basically create a new object, put a new and do that. would also do something similar to just like the question above here. I have also hinted at everything here. Let's see. Chroma create collection. And let's put in the parameters, which will be the which will be the name, the embedding. You guys can also add like something along the lines of a metadata so that you can easily identify the collection, the metadata base. To do that, you guys would basically just type in metadata. Right. This would basically provide a quick way for you to determine I the database if you have like many. But anyway. Oh, blah, blah. But yeah, after you run it, having no warnings, we're gonna move on to adding all the chunks that we have created with the hybrid chunking into the vector database itself. Okay. I've already set the ID, like the whole algorithms to properly pull in IDs and like metadata for each of the chunk. Like you guys to basically just put in those two into the collection app. So we have the documents here represented by the hybrid chunk text that we converted from our template into just a usable form for the we continue that with ID IDs as we have said above. You can also like look at the parameters here. This should be good. On it, adding documents to Chroma. And after it successfully store every chunk that you have created inside of the vector, and it would be almost to the point of where you can search it. Which is the next task I want you guys to do to code the implement what is it? The searching method of the Chroma DB. And to do that, just follow me guys here. So you run the option, which is the and then you would add query the database. And then inside the query, you would have parameters of query would question. So we would have query text equals to basically our own query. Alongside that, there's also end results. Which you can see here, end results in equal 10, but we would take only like 3. So end result is basically representing how many relevant results you want it to search back. Which we set it on top of the function, which is 3. So just put it as equal to n with it. It'll be good, no warning, so we can just step into the function. And then after that, I would like you guys to run this code block to see if you guys can access the Gemini Flash preview model. Basically, just confirming your API works. If anyone is having trouble running this at this point or like reaching up to this point, you guys can raise your hand. If not, we will continue. Still running, testing out the Gemini Flash model. We'll finally go to the phase of assembling everything together into a single pipeline, so that input and output would just be user ask question and then output it. This is the way to simplify it. So yeah, we have a step by step here with some hints. First, we should retrieve the query just created up here. Sorry, we should retrieve the relevant documents using the retrieval method function just created. Yeah. But anyway, let's code along. We have a variable question here, which will be representing the user query. And that will be also our first parameters. Question. Along with end results. We basically get like only the 3 most relevant answers. Okay, next up is after it retrieved the documents, we should put it all into the context. And context. Okay, yeah, there is an algorithm here, but I guess you guys can just go through the retrieve doc as a loop and then just append all of the strings together. But I will also type okay. Up to this point. Now we'll continue to actually creating the augmenting prompt. So let's let's just delete this. And to write it, just begin with the system prompt, and then the context, then the question. So we're automatically assume which model nowadays automatically assume that usually the first section, first paragraph, basically anything that you don't specify will be the system prompt. So you can just straight up say that I would want the LM to be basically you are a helpful assistant, something like that. Right. Sorry for my slow typing. I'm prepared on provided context. Yeah, okay. So this would be our system prompt. You guys can also specify it as system prompt. So something like this. Next up would be the context. There's context, and then your brackets so that you would have the context variable outside, pulling that from up above here, along with question from the user, also in brackets because we have that variable. And then for answer, you guys can just put it as empty, but you guys can also specify it to for like our answer format that you want. Basically, I would want it to be like concise and clear, so I would just say it to be. Yeah, this would be your augmentation. This follows very closely with most of the prompts that the company use. So yeah, let's continue to just generate a response. And to generate, I would like you guys to just go up here, similar to how we do the testing. Copy here. This would be a similar thing. But except for the contents, we would just put in the variables prompt. Yeah. So after this, when you run, it should be it should run as fine. This would just be a function. And for the final code block, run it and see how it there. Recently, I was generating. Gosh, okay. I might have missed a parameter. Oh yeah, there's an S. God damn it. Okay. S. What people? People and the generation. Okay. Yeah. I have saved three questions. What is the main topic discussing a document? Summarize the key point, and what is the So we would have it generating the answer to those three questions. It also tells us it doesn't have context here. Then, yeah, this seems like the paper that I read. Yeah. But yeah, you can apply this to any document that you have, or like multiple documents, maybe like up to 3 million documents. I don't know. You guys can scale it up like way, way more. But one like haven't been able to reach this step, like are confused on like what how pipeline works. Okay, if not, then yeah, this should be it for the notebook. I would go. I would also like to read.
Why that's and everything that might be topic.
The retrieval documents.
Answer.
Either or I guess increase the end results or relevant documents. I'll just really change the functionality. Yeah. So that's it for the code along. I would want to touch a little bit upon how you can use it in interest and audio. For these two stuff, you can treat image and audio as one and the same. Like, audio, you have to be able to analyze throughout the audio and image that you have. First is clip the contrastive language is different modalities as like two different languages. And if you have like, for example, if you have like two friends, two different languages, they wouldn't understand each other at all. They wouldn't know like this word in like Chinese, Vietnamese, or like Hindu is similar to this if they only speak that language. So, order like two friends together into one friend which who is like bilingual, and because they are bilingual, they can understand how relevant your query is both modalities. So you can ask them like query them like all you want to ask text and then it will back the relevant. Second method you can use is a vision or an audio language model. This is not like this is a different way for the model to understand image. Vision and audio language is language. And the reason this is relevant because after just like the notebook thing, audio language model basically describe an audio patch or an image patch and convert that to different pipeline. What is it? The image or audio with text. Audio, either clip, then audio clip would be faster, but it's where while vision and audio language model would provide you with a variety of descriptions, but in return it's much more slower to encode and it takes longer to pre-process it. But it would have a very high accuracy. This would be for you guys being here. But yeah, any question, you guys? Any question about the pipeline, about the image, audio? Okay. You guys don't have any question, but you guys would want to look into it, look into how to basically scale the text pipeline, the text retrieval pipeline. This is my Thank you again for being here. Just grab pizza on the way out. Session. I will be staying here, so any questions? As well. So, number. Can I get everybody? Oh yeah.
The setup. Hello, everyone. So my name is Ryan Wu. I'm a computer science PhD student here at ASU, and I'm actually conducting a survey on what computing competencies students feel are important for them to learn while they're studying here at university. So if you guys have 10 to 15 minutes of your time to just fill out an online survey, I'd enter you into a drawing for one of $300 Amazon gift cards, and it'd greatly help us improve the curriculum here at ASU and as well as other institutions in the US teaching computer science. Potentially. Yeah. To give some background if anybody cares at all, we're replicating the survey at Georgia Tech and Purdue as well, and some other schools in between, surveying faculty and employers as well to see if there's discrepancies between what they're wanting to teach, what students want to learn, what employers are expecting them to have. And the more of you guys that fill it out, the more strength and validity there can be to our results, better arguments we can make to try to improve curriculum for cohorts that come after you guys. Might not make it in time for before you guys graduate, but yeah. Yes, there is a huge discrepancy. You just need the evidence for it. Evidence to claims, yeah. Yeah, the flyers should have been passed around the room by my research aide. I think we still need to hit that side of the room, but yeah, we'll come around. I haven't checked yesterday. If you check out the distributions, there's a bar chart per day. Yeah, you can. Yeah, it's just we can't press the logo. It's fine.
Accuracy of your model. Schools. Grad student, so. Try to get my. I'm in my third order, like electric, talk to that one. We managed to get a bunch of. Cadence theory.
I thought you were that's What's your name? Yeah.
Else.
Oh no, I think this that's happening this day in Phoenix. Yeah. Yeah. It allows. Yeah, in Saturday.
But not A, I don't know about agent AI recently.
Right.
April.